All right, welcome back to the next video in this distance learning series for pre-calculus. Today we're going to talk about the law of cosines. So yesterday, or the last video I should say, we talked about how to solve triangles with the law of sines. And of course, for those kind of triangles, we had to be given two angles and any one side. Today we're going to be talking about a couple different cases and something called the law of cosines. So let's kind of jump right in here. What is the law of cosines? Well, it's got three different like formats to it, and the three different ways you might see it if you're looking at textbook or something like that. But I'm going to show you the first one here, kind of the most common way. And I want you to look at the first part of this. Notice this probably looks familiar to you. This is just the law. This is just the Pythagorean theorem, but it has this added piece out here. Now, I will add a link to a proof of the law of cosines, because it turns out it really is a stronger case of the Pythagorean theorem. No longer do we need a right triangle. If you remember your unit circle, notice if we have a right triangle and that opposite side there is C, and that's where the right angle is, we know the cosine of 90 degrees is 0. So that whole term would cancel out. But notice now, if we don't have any hypotenuse, there's no right angle, now it doesn't really matter what that opposite side is. So all three of these formulas here are the law of cosines. They're just rewritten with different opposite sides. I want to point a couple things out to you. It's pretty easy to remember this if you think of the Pythagorean theorem, because look, on all three of those, that opposite side and the angle is always kind of on the outside of that formula, and then the insides are the other two sides. Okay, so I am going to encourage you to write that down, just so you can have it on your piece of paper as we start going through these and when we look at the assignment and all those good things. Just like with the law of sines, when we draw a triangle, remember those uppercase letters always going to be the angles, the lowercase letters are the sides. And of course, when we draw, just like before, it doesn't really matter where the A, B, and C are, but just the angle A and the side A, and the other letters are always going to be opposite from each other. Okay. So again, if you need to pause the video and kind of write those formulas down just so you can have them for easy access for later on, I would encourage you to do that. So let's go and take a look at when we use law of cosines. There's actually two different cases for these, and I'll do an example of each case. The first case is when we're given two sides and the included angle. And I'll talk about that in just one second when we start doing the example. But the steps are very similar to what we did with the law of sines. We definitely want to draw a triangle and kind of label the sides of what we have, and what do you know, what do you don't know. And then we're going to use the law of cosines to find the third side. We're going to do that first. And that's just going to be kind of what I call just a plug and chug, and be able to go through there. And then once we have that third side, then we're going to use the law of cosines again to find one of the missing angles. Doesn't really matter which one we find first. It is going to involve some algebra, and then using an inverse trig function to isolate that angle. But again, we'll take a look at that in the example. And then once you have that second angle, well, the third angle we can just subtract, because just like we did with the law of sines, once you know two angles of a triangle, you can just subtract the sum of those two from 180. And the same reminder as before, make sure that whatever calculator you're using, whether it's Desmos or a normal calculator, whatever, make sure that calculator is in degree mode so you get the correct answer. Okay, so let's go and jump in here. Let's look at our first example. So I'm going to give you angle A is 25, side B is 10, and side C is 17. I just drew a random triangle that kind of fit over there. But if I label those in there, that's what it would look like. And notice, I'm going to talk real quick about the included angle. Notice that angle A there is between the two sides given, if that makes sense. So that's why we call that the included angle. If I'd given you angle C or angle B instead of angle A, those two are what we call non-included angles. Now, just a quick little aside, there is a way to solve that. If I gave you those same two sides in just angle B or just angle C, we can solve that triangle, but that's what we call the ambiguous case, and that's actually going to be the next video that I make once we get through the law of cosines, okay? So again, so we know that angle A and side B and C. We don't know side A and angle B and C. So we're going to go through and find those guys. Just to recap, bringing the screen back up again, remember we're going to find the side first. Do that right off the bat, and then we'll find the other two angles. Okay, and again, kind of your last chance, in nice big letters here. If you want to write that down, I am going to have I'm going to have the law on the screens as we solve this, but make sure you have it written down before the end of the video, so when you start doing the assignment, you don't have to have it memorized. So, finding side A. Notice we can pick which one we do, but the formula we're going to use, we need to know everything else except for that side A. And notice the last one there. If I choose that bottom equation, then I know little b, little c, and big A. So this is just, again, what I call kind of a plug and chug. So a squared equals 10 squared plus 17 squared minus 2 times 10 times 17 times cosine 25 degrees. Well, all I got to do to find out what A is take the square root of that whole thing. Okay? And I just put that in Desmos, and I will change my screen here just to show you real quick, put that in Desmos. So I'll bring up the keypad here and do the square root. And notice I'm letting the calculator do all the work for me. Plus 17 squared minus 2 times 10 times 17. And then I need a cosine, so the function key, and 25. Now, you might be saying, oh, okay, that's the right answer, 7.22, but wait a minute, go over to your wrench or whatever settings you have on your calculator, make sure that you are in degrees, and notice it kind of defaults to radians, so if I hit degrees, it'll automatically change that answer, and that is the correct answer. That's why it's 8.99. Okay, so again, pop everything in the calculator, just let the calculator do the work, and so my side A now is 8.99. So now I'm going to find the angle. I'm going to go and find angle B. I tend to like doing things alphabetically. So if I do that, and again, now look at your law of cosines over here. Which one of these formulas tells me how to find angle B? And that would be the middle one. So again, plug everything else in that you know. I know all three sides now. So if I plug that in, the formula looks like this. Okay, but the problem now is I have to isolate that. I have to get B by itself. Okay, now I know some of you might be saying there are certain calculators out there that that you can type that thing in and it will just solve it for you without doing any algebra. As a math teacher, I want you to do the algebra. So when you're doing assignments, the expectation is you're going to show the steps to isolate B, and then you can put all of that mess in the calculator to get the final answer. Okay? So this is what it's going to look like. I did it in one step, but I'm going to kind of highlight and color code things so you don't get, so it's not kind of too overwhelming for you. So here's what it looks like. So notice the first thing we got to do, if we're getting B by itself, I need to subtract the 8.99 squared, and then I'm going to subtract the 17 squared. And then this whole next quantity, that negative 2 times 8.99 times 17, we're going to divide that whole quantity. Okay, so then what's left over that I got to get rid of? I have to get rid of the cosine. So we know from a couple units ago, to undo a cosine is the cosine inverse. So that's why that's the whole thing. So it's the cosine inverse of, again, that whole thing. Let the calculator do the work. And then that's going to be their answer. And I'll type that in to Desmos for you also, just so you can see what it looks like. So go back to my Desmos here. And again, on the functions, here it has the inverse cosine. Make sure you're using the inverse. You have the division key, make a fraction. And we got 10 squared minus 8.9 squared minus 17 squared, all divided by -2 times 8.99 times 17. And again, I'm already in degrees, I already checked that, so that's why my answer is going to be 28.02. Okay, and again, whenever you put these things in the calculator, just kind of triple check everything's in there correctly and everything's in good shape. Okay, so now I know my angle B. Now all that's left is find angle C. Well, look, I know angle A, I know angle B, I know triangles always have 180 degrees. So all we do is just subtract. So you got 180 minus those two angles, 126.98. Lo and behold, that's it. And then you have solved that triangle. Okay. So here's the next one. I'm gonna have you pause the video for a minute and see if you can work through that. Feel free to go back through that last example. This is another side angle side case. You see how I label the triangle. Go ahead and pause the video, and then we'll go through the answers here in just a couple seconds. Okay, so hopefully you have worked this out. Let's see what it ends up being. So in this case, again, I want to find the side first. So for side C, I'm going to use that top equation over there, that top formula. Plug it in, and then all you got to do in this case, whenever you find your side, is take the square root of that whole side, let the calculator do the work. I'm not going to go back to Desmos this time, just in the interest of time, but that's kind of where we are now. And I apologize for not going back to that full screen there earlier. So my side C is 14.41. And then to find angle A, I'm going to use that bottom formula, because that's where the angle A is. And again, plug everything in, isolate the A, subtract the 13 squared, subtract the 14.41 squared, divide by that whole quantity, take the inverse cosine, just undo everything, put that in your calculator, and then you should get 24.60 degrees for angle A. And then for the third angle, just subtract, and you should get 61.40 degrees. Okay, so if you didn't get those numbers, I think the one thing that I would just double check is make sure your calculators are in degrees and you're typing it in correctly. But just go back through and double check that process. Okay. Now we got to talk about that second case. Remember, I mentioned there were two cases of using the law of cosines. So that side angle side case is the first case. The second one is for side side side. But listen, there's no difference. We're still going to draw the triangle, but this time, since we have all the sides, all we have to do is find the angles. Okay, so we're going to do exactly what we just did, but use that twice to find two of the angles, and then for the third angle, again, just subtract. So this one's going to go a little bit faster, I think. So let's go and jump in and take a look at this example. So given all three sides, A, B, and C, and again, I just drew a random triangle, doesn't have to be to scale, stick in the numbers there, and again, we don't know the angles, so you can find them in any order. Again, I like doing things alphabetically, but you can do them in any order you want to. So if we're going to find angle A, I'm going to use that bottom formula, plug everything in, isolate the A, and I think you see how to do that now. So that'll come out to be 53.72. You repeat the process one more time to find angle B. In this case, it'll be the middle formula. And again, plug everything in. When you put in the calculator, just be careful that you're putting it in correctly. And that'll come out to be 37.78. And then for angle C, we're just going to subtract those two angles that I know that I just found, and that should come out to be 88.5 degrees. And that's it. So there's no difference in process. It's just a matter of, for the side angle side case, you have to find one of the sides and then find the angle. In this case, we're just finding both angles. Okay, so again, I'm going to have you pause the video. Here's a side case for you to do on your own. Pause this and see if you can see if you can find those three angles by yourself. Okay, so again, finding angle A, plugging in all the numbers, isolating, put in the calculator. So we have angle A is equal to 109.83 degrees. Same thing for angle B, plugging all the numbers in the correct order, isolating. Oh, and I just realized I made a little typo here. That this should obviously be angle B. I apologize about that. That should be angle B right here. But angle B will be 50.78. And then finally for angle C, just subtract all those guys. So we've got 19.39. The one thing I do want to point out real quick is once you find the angles, notice the biggest angle went with the longest side. And then the medium size angle went with the medium length side, and the shortest angle, the smallest angle, with the shortest side. That's always going to happen. So it's kind of a good little cheap way to check your work, because the longest side and the biggest angle will always kind of be paired up together. Okay. So that's how you do the law of cosines. Just like I did in the Law of Sines video, I encourage you just to make up some of your own problems. I'll put that same link to that website where you can just type in random sides or angles, and they'll spit out the answer, so you can check your work. There is going to be a short assignment posted up on Google Classroom. Remember the cases where you use them. If you're given two angles or a side, that's law of sines. Or if you're given side angle side or all three sides, that's law of cosines. You might also see some word problems, some applications, like using angles of elevation or stuff like that. So you can see some application problems with these also. There is one more case where we use the law of sines. And that's something called the ambiguous case. I referenced it real briefly a few minutes ago about the non-included angle. So look for that video early next week. Please feel free to share this video. Feel free to subscribe. I am putting some videos up also for some Algebra 2 topics. So please feel free to do that if you're so inclined. And I put the law of cosines there in the bottom of the screen for you one more time, in case you still need to write that down. Hope you found this helpful. If you remember, you can always contact me. I'm in that Google Meet room. The link for that is on Classroom, or you can email me or email your teacher if you don't have me or what have you. Have a great day as we're still adjusting to all this kind of distance learning stuff. And stay healthy, stay well, and keep studying.